Okay, so today we're going to talk about the local area networks. We're going to go into some general theory of Ethernet switching, and then we'll look at some design and configuration on the command line. And first, Jeremy had a question about what we talked about yesterday with the configurations on the devices. So making backups of the configuration as opposed to the software or the iOS image that we looked at yesterday. So with the current setup, I still have everyone from yesterday in the subnet 192.168.0.0/24. And the rest of the devices have just a very basic configuration where the addresses are assigned to their Ethernet interfaces. And the switches don't have any type of VLAN configuration or anything like that. So we should be able, from all of the routers, to be able to ping this Windows machine that has the address 192.168.0.100. Now, in most real designs, you would see that you would have some sort of management server, like a TFTP server or an SNMP server, that's probably not on the same subnet or not on the same VLAN as the rest of the machines. So we'll talk about that later when we get into routing and different types of management techniques that we can do remotely when we're going over a layer 3 routed network as opposed to just the layer 2 switch network that we're going to look at today. But assuming that all of these routers have basic connectivity to the server, this is really all that we need to verify from the layer 3 of the OSI model, which again means that if I can ping from the management station, which is the Windows machine, if I can ping all of the routers, then I can assume that there's nothing wrong with the physical cabling, there's nothing wrong with the Ethernet configuration, there's nothing wrong with the basic IP addressing. So again, when you're testing the network, this is always a very good basic tool just to eliminate problems like the router is powered off or like the interface is unplugged. So additionally, we have this application that's running on the server that is the TFTP server, or the Trivial File Transfer Protocol, that again is mainly for management, where we're using it to upload and download iOS images, or also for the configuration files. So if we were to look at some of the routers and look at their configuration, let's say on switch 1, for example. And on switch 1, we can look at its current configuration. If we look at either the show running config or the write terminal, this is going to show us any changes that we've made since the original defaults. Now, the details of what a lot of these commands mean we'll talk about later, like what is the switch port mode command, and what does dynamic mode, what does desirable mean. But we see it has a basic initial configuration with a host name. And on the VLAN 1 interface, we have an IP address. This is what is allowing us to reach that Windows machine, which is 192.168.0.100. So assuming I can get this far, I should now be able to make a backup of this device's config to the TFTP server. And typically, the way that you save your config locally to begin with is either to say copy running config to the startup config, where startup config is the local backup copy of it. This would also be the same as saying just write, where the shortcut for this is WR. Now, if I want to back up the config not to my local NVRAM or the non-volatile RAM, if I want to back it up to the server, I need to say copy the running configuration to the TFTP server. So you can use a number of different network protocols for this. You could use an FTP server if you wanted. You could use the Unix or Linux remote copy protocol. But probably the most common one is going to be TFTP, the Trivial File Transfer Protocol. So we would say copy to the TFTP server. And either if I were to press enter here, it's going to go through a dialog of asking me questions like what's the address that I want to copy to. This would be the server's address, so the 192.168.0.100. And on the Windows machine, we can verify this if we look at the IP config, where this is the address here that we're using to reach the rest of the routers. So we're copying this to that machine, 192.168.0.100. Destination file name by default is going to be the host name dash CONFG for its config, but we could set this to whatever we wanted to. So let's say I want to do this with maybe like a timestamp. Like this is sw1.1025.2011.cfg. So it could be whatever file name that I want. So you can see it's a fairly small config. It's only 2100 bytes, so it only takes about a second or two to copy it. But from the server's point of view, it's essentially configured to listen for any of these files. So if we look at now, it says this current directory, that's where it's saving it to. So what I'm going to do is make a new folder on the desktop. We'll say that this is our TFTP directory. And then this is where I'll save the rest of my files. So on the desktop, TFTP in this folder. So now from the switch, if I do this again, run the copy command again. So copy running config to TFTP, the address, and then whatever I want to name it. It should now be in this directory here. Now again, if we were to actually open this file, like if let's say we open it in Notepad, it's different than a regular text file. So it's a little hard to read this from the actual server. So if we go File, Open, on the desktop, this is TFTP, then All Documents. You can see it has some extra characters in there. It's not a regular DOS file, but in general, this is what's saving the router's config. Now, if at a later time I want to take this configuration and load it back to the router or the switch, the procedure is going to be the same. Let's say, for example, that the configuration got erased. So someone said write erase, or someone said clear the startup config. That's erasing everything in NVRAM, which is the backup. If we look at the show startup config, it says the startup config is not present, which means that now if I reload the switch, it's going to go back to its blank defaults. So if I want to take the backup that I have here on the server and now copy it back to the switch, I'm going to do the same procedure, but it's going to be in the reverse direction. So I would say copy from the TFTP server to my startup config, where the server is 192.168.0.100. The source file name is whatever here is on the server. Oops. So copy TFTP start 192.168.0.100, and then this is the file name. Destination is startup config. So now we copied it back. If we look at now the show startup config, we should see now the backup that was from the server is back on there. So one of the advantages of this is you can configure some sort of like management scripting to go into the devices and say maybe every day at midnight I want to copy its config off and copy it to a new file name just in case I want to make a look at the changes between one day and another. So there's a lot of different types of management applications that do this. The one that Cisco traditionally used is called Cisco Works. Cisco Works LAN Management Solutions is a suite of powerful management tools that simplifies the configuration, administration, monitoring, and troubleshooting of Cisco networks. So it's basically like a centralized GUI interface that's used to manage all the routers and switches. There are other ones that are available. A popular one is SolarWinds for network management. And as a general term, what these are called is network management systems or network management stations. So if you search for NMS is the abbreviation for it, you'll see all sorts of different hits that come up for it. Most of them are going to be paid applications. There are some freeware ones out there. So network management system or network management station. So here's like an open source one, OpenNMS.